to determine depreciation using three different methods. The straight line method, which is the most common form of depreciation used for financial accounting. Sum of the year's digits, and double declining balance. Double declining balance is the basis for the IRS's tables known as macros. So double declining balance extensively used in income tax preparation. And straight line is the primary method used for financial accounting. The advantages of using Excel to determine depreciation that allows you to quickly change the inputs to determine depreciation, creates a model where you can do sensitivity analysis. What if this changes? What if that changes? So Excel is a useful tool in doing that. Speeds up your calculations. We're going to start with an example of a piece of equipment that cost $105,000. We have two estimates: the estimated salvage value, which we have pegged at $5,000, and we have established an estimated useful life of 5 years. For the straight line method, we're going to set up our cost, salvage value, and estimated life in the worksheet so that we can quickly change them if our inputs change. I'm using Office 2010. Your format may look a little bit different, but somewhere on your screen you'll see a tab for formulas. The depreciation formulas are in the financial category. And we'll scroll down and we're looking for SLN, which stands for straight line depreciation. When the argument box comes up, it's going to ask for three things: the cost, the salvage value, and the life. We have set these up so we can reference cells. For our cost, it's going to be cell B3, salvage value B4, the useful life, 5 years. We have our cursor in the annual depreciation amount. We hit OK, and we quickly determine that the annual depreciation using the straight line method is $20,000. We're going to need the same inputs for the sum of the year's digits. Again, we will go to financial. We will scroll down to SYD, sum of the year's digits. In addition to the three inputs we needed before, we also need to tell the program what period that we're looking for. Unlike the straight line method, sum of the year's digits and double declining balance will have different depreciation amounts over the useful life. So again, we're going to reference the cost. Here's cell B9, salvage value B10. The useful life is 5, and the period is period number 1. So let's hit OK, and it tells us that for year number 1, the depreciation will be $33,333. We would then repeat these steps for years 2, 3, and 4. We have our cost, we have our salvage value, our life, period, which is now C12. Annual depreciation for year number 2. Now, a little trick to speed this up: we can copy and paste this by anchoring in our three variables. We're going to anchor in cell B9 by placing dollar signs in front of the B and the 9. That's going to lock in the cost. We're going to do the same for the salvage value. Place a dollar sign in front of the B and the 10, and then do the same thing for the estimated useful life. That will lock the formula onto these three cells, leaving only the period as the variable. We can then copy and paste, and that will give us the annual depreciation for periods 3, 4, and 5 without having to do the argument over and over. A slight variation of this we can do with the double declining balance method. We'll put our cell in the depreciation for period 1. We're going to go to our financial, and we're looking for DDB for double declining balance. Instead of referencing the cell, because I know I have to do this for multiple periods, I'm going to type in the cost, $105,000. The salvage value is $5,000. The estimated useful life is 5. And for the period, we're going to reference cell B19. Once we do this and hit OK, we will have our cost, salvage value, and life locked in. The only variable will be the period. As we copy and paste the program, we'll pick up the appropriate period. This last box, factor, allows us not only to do double declining balance, which is the default, so if you leave it blank, it comes back to double declining balance, but you can use 1.5 times. You would put in the factor of 1.5. That's not called for here, so we'll just go ahead and hit OK. That returns us a depreciation for period 1 of $42,000. We would then copy and paste them for years 3, 4, and 5. While Excel doesn't have a function to determine units of production, it's easy to set up a worksheet that can calculate the period depreciation for you. Again, we're using the same example. Instead of doing useful life in years, we're doing it in units. We estimate that this piece of equipment will manufacture 1 million units over its lifetime. So the first thing we have to do is determine the cost per unit. And the cost per unit is going to be given by taking the cost, and we're going to set up a formula, so we'll tell Excel it's a formula by the equal sign. We're going to be taking the cost and subtracting the salvage value. Let's open up parentheses and take the 100,000 and subtract out the 5,000. That gives us our depreciable base. We will then divide it by the useful life in units, and we'll come up with a per unit cost of 10 cents per unit. Let's say in the current year, we produced 250,000 units. To get the period depreciation, we will take the units that were produced, 250,000, multiply it by the per unit amount, and we would have an annual depreciation of 25,000. Again, the beauty of Excel is that for future years, since production will change each year, if in year number 2 we produce 350,000 units, we type in 350, and the program automatically gives us the new period depreciation. So Excel can be used to speed up your calculations, to create a nice worksheet, to show how depreciation was set, to come up with a depreciation table to show depreciation over the years, and to do modeling, where we would take a look at what if scenarios. What if we purchased a more expensive machine for $150,000? What would be the difference in depreciation? Excel quickly can tell us the amount. So hopefully you'll be able to use Excel to speed up your calculation of depreciation.